Okay, so we're taking a look at some exponent laws here on pages 5 and 6. These are some examples that will help you with the homework. Okay, so we'll start with number 6. So in this one you can see 3 to the 7th times 3 to the negative 4th over 3 to the 4th. Now, my suggestion for this is that we would go something like this. Let's combine the top part together. 3 to the 7th minus 4, because the two exponents add, over 3 to the 4th. 3 cubed over 3 to the 4th power, and then take the larger one and subtract the smaller one from it. So I'm going to take this one out from 4. So I will be left with 1 over 3 to the first power, or just 1/3. Okay, and by subtracting the smaller one from the bigger one, you'll always avoid negative exponents. And one of the goals is to always simplify away from negative exponents. Here's another fairly straightforward one. The only thing you have to really remember is that when you have exponents on top of each other, they're going to multiply together. This just comes out to a to the 6th power. So number 12, fairly easy, straightforward problem. Not much to say about that one. Here's one that's a little bit trickier. Okay, so we have 2a to the negative 1 squared over 2a to the negative 1 to the negative 2 power. Okay, so a couple of things that can happen here. Okay, I'm going to start with this negative exponent, and to get rid of it, I'm going to move it to the top of the fraction bar. So I'm going to have something like this, 2a negative 1 with that squared, and then this one that I'm moving from the bottom will be another 2a negative 1, and it's also going to be a square. So when you move this to the top, it will change the sign. Okay. Now let's go ahead and distribute this exponent in with all of our pieces. So I have something like this, 2 squared a to the negative 2, 2 squared a to the negative 2. So I distributed each of these in. Okay, and I'm not going to square the 2's yet. I'm going to wait until the end and then I will calculate what they are. So if I take these and we combine all of our like terms together, okay, and these are all over 1, we get 2 to the 4th power a to the negative 4th power. Okay, and I'm going to go ahead and move this a. Same way, let's move it to the bottom and change it to a positive 4. And then finally, now I'll compute what 2 to the 4th is. So 2 to the 4th power is 16 over a to the 4th. And that's my fully simplified form, right? So remember, you can change the sign of the exponent and move it to the opposite side of the fraction bar. Here's another really good one with a negative exponent, problem number 26. Okay, so in problem number 26, we see this negative exponent, and one of the quick tricks we can use to correct a negative immediately is just flip your fraction over, and now it will be a positive exponent. Okay, now this 3 over 2 is going to apply to both of these. It applies here and down here. Okay, now one thing to understand, the 3 represents a power or an exponent in this case. Okay, and the bottom number in this case is a root. Okay, so when you see a 3 over 2 or 1/2, that means you have a root of 2 involved in this. Okay, so we always like to start with the root because it's going to make the number smaller than if you were trying to do the power. Okay, so let's start by just saying, okay, I have 25 to the 3/2 and 9 to the 3/2. Okay, and if we start with just the root portion, you can ask yourself, well, what are the square roots of these numbers? So the square root of 25 is 5, and the square root of 9 is 3, and these are being cubed, okay? Which means what do we get finally? 5 cubed is 125, and 3 cubed is 27, so 125 over 27. Okay, so again, the main thing to understand is when you have an exponent, first, negatives cause the fraction to flip, and the bottom number of your exponent is the root value, actually. So in this case, with a 2, we are taking a square root and then cubing the number. Remember, if you do the root first, it will help you because it will make the numbers smaller. Okay, let's take a look at problem 28. So 28 has 16 to the negative 3/4 to the 5/4 power. Okay, and this one is kind of interesting. Let's just note that when you have exponents on top of each other like this, we can just multiply them together. Negative 3/4 times 5/4, which gives us 16 to the negative 15 over 16 power. Okay, sorry, this is a little messy. Now, I'm going to use the fact that that exponent is a negative to cause this to flip over the fraction bar. So 1 over 16 to the 15/16 power. Okay, and we could also rewrite this in another way, which is 1 over 16 to the 15th power in the 16th root. Okay, so just remember that the bottom number here, that is the 16, is also the same as the root. Okay, so when you see a piece like this, you can always think the top part is a power and the bottom part is the root. Okay, so when you have a fractional exponent, the bottom number is always the root of that. Okay, this one is kind of a fun one. They've given us on problem 36 square root x, cube root x, and then the sixth root of x. Okay, so what we're going to do is we're going to take these and we're going to rewrite them as exponents first, so we can use our exponent rules to simplify this. Okay, so starting with the first one, which is a second root, so this will be x to the 1/2 power. And if you see the cube root of x, that will be x to the 1/3 power. And the sixth root of x will be x to the 1/6 power. Now, what happens when I multiply these three? The exponents get added together. 1/2 plus 1/3 plus 1/6. So when we add these together, you actually get that this comes out to x to the first power in total, or just x. Okay, and here's problem 38. So this one's kind of cool. We have n to the 1/3 times parentheses n to the 2/3 plus n to the negative 1/3. Okay, so when we do this, we're gonna go ahead and let's lead out by distributing. But what happens when we multiply these? We get exponents that add together, 2/3 plus 1/3 and n to the negative 1/3 plus 1/3. And you may say, okay, well, 2/3 and 1/3 makes a whole. That's n to the first plus n to the 0 power. And this is kind of the cool one. What is n to the 0 power? Well, anything to the 0 power is just going to equal 1. So this becomes n plus 1 in its most simplified form. Okay, another fun one. We've got number 40, where we have a squared b to the negative 1/2 on the bottom of this fraction. Okay, so the things to look out for, again, we want to get rid of all the negative exponents. And the first thing I'm going to do is I'm going to say keep these two together as a group right now, because what I'm going to do is move this one up as a squared b to the positive 1/2 power. Okay, and I'm going to use this and we're going to end up distributing it in there afterwards. So first I'm going to clean this piece up a little bit to make our life easier. So what I have right now is this: 4a b to the negative 1/2 minus 2a b to the 1/2 all times, I'm going to distribute this 1/2 in, a b to the 1/2. Okay, and so now when I multiply these terms, when I multiply them, their exponents will add together. So let's distribute this to the first term. So I'll keep my 4. I have 1a here and 1a here to make a squared. And 1/2 and 1/2, that becomes b to the 0, negative 1/2 plus a half. Okay, so when I do that, I get that minus, when I distribute over here, 2a squared, because we got 1 and 1, and then 1/2 and 1/2 makes a full b. Okay, 1/2 plus 1/2. So now, remember, b to the 0 power, anything to the 0 power, is just going to become a 1. 4a squared minus 2a squared b. And of course, I don't really need this one, so we end with this. 4a squared minus 2a squared b. And there you go. We have our simplified answer. Okay, so now in the bottom section, we're looking at slightly different problems. We are using the properties of exponents and common bases to help us solve these problems. Okay, so in a situation like this, I'm always going to look for, can we rewrite these using the same base? Okay, if you can get the matching base or a matching exponent, it becomes very easy to solve these problems. Okay, so the first thing I noticed is I said, well, 9 and 81 both come from the same number. 81 can be rewritten as 9 squared, and that is 9 to the 4x. So guess what? Since these are both base 9, they are equivalent, which means my 4x and 2 must also be equal. And if you divide by 4, you will get that x is equal to 1/2. Okay? Now, just as a statement to show that you could do this with any base, okay? Let's say you decided to rewrite both of them. What if you rewrote 9 as 3 squared to the 4x power equals 81, which is 3 to the 4th power. Okay, I just want to note this is equal to 81. Okay, and if we simplify this, we get something like this. So 3 to the 8x equals 3 to the 4th, and so 8x equals 4, and x equals 1/2. So look, even if you made it base 3 instead of base 9, you could still do it as long as you can get the two bases to match up, right? So a lot of what you're going to do is turn a base or both sides into the same base so that we can set the exponents equal to each other. Okay, and here is number 50. This one is another really interesting exponents example. However, instead of setting the bases equal, we're going to try and get these exponents to actually match each other. So 27, I'm hoping you've learned this one by now, is 3 cubed. And that gives me this statement, 8x minus 2 cubed equals 3 cubed. So now, once I have this, I can say, well, these cubes are going to cancel each other out. And I have 8 times x minus 2 is equal to 3. We can divide by 8, 3 over 8. And let's add our 2 to this, plus 2, plus 2. And remember, 2 is the same as 16 over 8. So I would find that x equals 19 over 8. And that would be my solution. Okay, so in this situation, if you get the two exponents equal, then you can cancel your exponents out and solve for the remaining missing terms that you have. Great. I hope you found this video helpful, guys. Good luck and happy studying.